Hi, my name is Manish Gupta, and in this video, I'm going to talk about a new interesting framework called as tree of thoughts. So let's get started. What is tree of thoughts? Now, it turns out that people have two modes in which they engage in decisions. It's called as system one mode and system two mode. System one is fast thinking, fast, automatic, unconscious thinking. System two is a slow, deliberate, conscious mode. It involves local exploration, so looking at various choices and exploring diverse alternatives and then making a good choice and then moving ahead, right? It also involves global planning. So it evaluates current state and actively looks ahead or backtracks to make more globally optimal decisions. Okay? So the way current autoregressive large language models work, they are more like system one, but there's a missing system two. You don't have any capability to look ahead or backtrack. You sort of explore like one path rather than exploring multiple alternatives and then deciding which is the best one. Right. So the tree of thoughts framework essentially enables exploration over coherent units of text called as thoughts, of course, that serve as the intermediate steps towards problem solving. Okay. So here is a good comparison of how various forms of prompting can be looked at. Okay. So if you think about the typical prompting, it's input output kind of prompting. Of course, it can be few short as well. So you can give a few examples and then do give input as input, and then you expect the right output. There's also chain of thought prompting, where you essentially give the input and then sequentially you sample a thought. And then finally, after a sequence of thoughts is done, hopefully you will get a correct answer, right? An output. Now, to improve chain of thought prompting, people have proposed this self-consistency with chain of thought, where the idea is that you sample several chains of thought, and then out of when you get the outputs, you basically make a majority voting kind of a decision. Now, these kinds of things sort of work in a classification setting where you can do majority voting at the end. And here is tree of thoughts. So tree of thoughts basically maintains a tree of states, and then it can basically at any node it can try to figure out, hey, what should be the next states. It can maintain a best set of states so far. It can do breadth first search or depth first search in search of a good output at the end. So tree of thoughts framework is supported by these four different concepts, which are basically required to maintain the tree states. It's essentially thought decomposition. Now you can think of thought. What is a thought, right? So thought could be a couple of words where you're solving crosswords, or it could be a line of equation if you're solving mathematical reasoning problems like game of 24, or it could be a whole paragraph or writing plan if you're trying to do creative writing using this kind of a large language model setup. The second thing to take care of is thought generator. So, at any point of time, you have to generate k thoughts. You have to generate what should be the next k thoughts to care for, right? Now, you could generate them in parallel, or you could generate them sequentially. So if there's a lot of scope, if the space is too diverse, then you can actually generate in parallel. But if the space is very, very constrained, then maybe it makes sense to generate these thoughts in sequence, one by one. Okay. State evaluator. Now, at any point, when you reach a particular state, you may want to continue further from that state or not. Right? And that's basically what state evaluator does. It evaluates whether the state is sure, likely, or impossible to reach to the final output. Now, the value of each state can be calculated independently, or it can be calculated by doing voting across all states, all current states, basically. Right? And then there needs to be a search algorithm. How do you want to explore these states in the tree? Do you want to go breadth first, or do you want to go depth first? If you want to go breadth first at any point of time, like beam search, you must sort of keep a track of maximum B states at any point of time. Okay, so how does tree of thoughts perform? So the authors actually looked at this or evaluated the tree of thoughts framework over three different problems: game of 24, creative writing, 5x5 crosswords. Now, they use GPT-4 as a base large language model. In game of 24, you use four numbers and basic arithmetic operations, plus, minus, multiply, or divide, to obtain 24. For example, these could be four numbers, and then you may want to get an equation of that kind as the output. Now, what you see in the blue thing is basically the thoughts that have been generated while doing this. The creative writing task is basically where input is four random sentences, and you want the output to be a passage of four paragraphs where each paragraph ends in one of those random sentences. Mini Crosswords is a 5x5 crossword problem where the input describes the 5 horizontal clues and 5 vertical clues. And the expected output should be a board of 5x5, that is 25 different letters to solve the crossword. Right? So essentially, that's the expected output. You want to basically come up with 5x5 letters, totally 25 letters. Okay. So they solve the problem, of course, using tree of thoughts, but they also compare with the typical input-output prompt, chain of thoughts with self-consistency. Right. So what you see here is a way in which the game of 24 problem is being solved. So essentially, you start with some input, and here you see the tree of thoughts. You also see that there is a proposed prompt kind of a thing, so as to explore more and come up with the next prompt, with the next with the next states. And then there's a value prompt, which sort of evaluates how good the current state is, right? So essentially, propose prompt sort of essentially helps you propose the next states, and then the value prompt sort of tells you whether you will be able to reach the final answer 24 or not using this current thinking that is there in the current state. Okay. What you see here is also, another visualization for the creative writing example. So you start with some input, and then in this particular case, they just explored the tree up to depth of 2, and at every level, they basically explored 5 different plans. So there are 5 different plans, and here is the input, right? A coherent passage of 4 paragraphs. So this is the actual input. You have the first plan, second plan, third plan, fourth plan, fifth plan coming from the proposed prompt of the tree of thoughts framework. And then there is also this voting kind of a framework which sort of tries to vote, hey, amongst these 5, which one seems to be the best? And then that is the one that they explore further at level 2, so as to come up with the final creative writing, 4-paragraph answer. Now, they of course compared, quantitatively across the various approaches: IO prompt, COT prompt, and COT self-consistency prompt. These are the results for the game of 24 problem. So as you observe, game of 24 is a relatively simpler problem, but they took the complex ones out of the simpler, rather than taking just the simple puzzles, right? And they observed that chain of thought basically gives you just about 4% success. IO prompt gives you 7.3, but but the tree of thought essentially gives you 74% correct results. Especially with B equal to 5 when you're doing breadth first search, keeping 5 best states at any point of time. Now, when you do creative writing, it's difficult to evaluate outputs of creative writing, and hence they use GPT-4 as well as human coherency, human annotators to evaluate the outputs coming for the creative writing. So they evaluate using GPT-4 and then also using the human annotator way. And what they observe is that in general, the scores that people gave for tree of thoughts is higher compared to a simple input output or chain of thought framework. Also, when you look at so this is the GPT score. When you look at human coherency comparison, people found the train of thought to be better compared to chain of thought 41 times, while they found chain of thought to be better than tree of thought just 21 times. Lastly, about the 5x5 crosswords problem, you can actually evaluate the output is a 25 character output. So you can evaluate the success in terms of, out of 25 letters, how many of them are correct. Out of the 5 words, out of the 10 words that have to be formed, how many of them are correct? Or the entire game, is the entire game correct or not, right? And they found that, again, tree of thought gives you much better results compared to the input-output prompting or chain of thought framework. So in short, the tree of thought provides a system to ability in some ways to large language models. It searches a tree of possible paths to get to the solution of a problem. It allows local exploration with multiple alternatives. It also allows for global planning with lookahead and backtracking. If you want to look at their prompts, you can have a look there. Hope you liked the video. Thank you for watching. Connect with me on my LinkedIn or look at my research on my homepage. Thank you.